Welcome to Physics with Mr. Brazil. Today we're going to be talking about torque on a spooled wire. There's a bar that this person can do pull-ups, and let's tackle it out. So let's say that we have, let's put a pen on here, and we have a tension on this wire. This spool is adjustable to adjust for people's heights and preference. We have this spool that has a radius, I. Let's make it R. You have this pre-made, but let's go on. The bar is evenly massed, so this bar is evenly massed at 2M. Yes, AP Physics loves variables, so we're going to do this with variables. Let's give the length of this bar, length of 3R, okay? And the mass of the person, let's make that 10 times M, okay? So I think we have everything we need. Let's see. If you don't understand your forces, draw a free body diagram every time. So we have 0 right here. So I'm going to go to the right. I'm going to put a 0 or a little dot for that 0. I make a right angle because it's right angle to the radius. So there's our tension. We're going to take our bar. We're going to extend it. We have FG of the person coming straight down. And we have FG of the center mass of the bar. Okay, and then all of a sudden, my jelly beans. Forgot something. Here's what we forgot. We need an angle. See, from up here, if we draw a line, we have this angle. I'm going to call it beta. Okay, so there's an angle beta. Well, that's good news because that means if we have the center mass and this object, if we draw parallel lines, if this is beta over here, here's beta, well, guess what? This will also be beta on this end. All right, so if this is beta right here, then beta is on the inside of this acute angle, all right? So beta and beta, so we do have an angle beta. So we can write up an equation in terms of MR and beta, and since we have Fg, so it's gravity. So if you've forgotten, Fg always equals some mg, some mass times gravitational acceleration. So let's write up our math. So we're going to have our net torque of the tension. I'm going to make that positive, and why? Always draw an arc. I like to use my right hand. If it's clockwise, then it's a negative twist going into the screen, and coming out of the screen is positive, counter clockwise. Okay, so clockwise is negative, counterclockwise is positive. That's what I chose, and I always draw an arc with a little dot and let people know what direction is positive, which direction is negative. It doesn't matter which way, just which direction a twist is, just make sure you tell people what it means. So that means if you go to the right here and look in orange, you can see that FG bar, my thumb will go into the dot, the 0, and my fingers will curl clockwise so that it'll be negative. So that's a negative tau center of mass and a negative, person. And since nothing is moving, we're just doing pull-ups, we'll keep the whole system static, equals 0. Or just letting the person hang from the bar, okay? Equals 0. So this will be the tension times R. Let's put sine theta is 90. That's just 1, not a big problem. We're going to have the mass of the bar. It's evenly massed, so let's say that is 2M. And the distance, though, is halfway in between the bars, so that's going to be 3R divided by 2. Okay, and it has an angle, so sine beta minus, okay, we're going to have the person, and so this is, person is 10 m, and also it'll be 3r, because that's the end of the bar, okay, evenly masked. I'll put a bar here so that people can see that. And it also will be sine beta, and that equals 0. Okay, so let's see what we have. We now need to solve for t. We also can get rid of a couple things, so we can get rid of the 2 here, okay? And let's go back. So t is going to equal 3, and all these I noticed something, g is missing. G is 10 mg and 2 mg, so I forgot that. So that'll be 3 mg r sine beta plus, because it's going to be on the opposite, so it's going to go to the other side of the 0, 30 mgr sine beta over r. Well, that's sweet. R is going to go away, go away, go away. Okay. And we're going to have like terms. So the answer will be 33 mg sine beta. That is the answer. Oops, that's not sine. Sine beta. Okay. So don't rush things. Take your time. Review this video again if you have to. But this is a great example of a wheel having various torques about it. So keep practicing physics and don't give up on this stuff. All right, till next time. Bye.